Hi, welcome to the statics tutorials. So we're going to look at the cross product and how to compute the cross product to work up to looking at how to calculate moments of forces. So with the cross product, you have a vector, say A, and you're going to cross it with vector B. And so the first step is just to figure out the direction of C. So use the right hand rule. You put your fingers going in the direction of the first vector, so I'm going to put my fingers going in the direction of A, and then I'm going to bring them around in the direction of B here, and my thumb is then going to go in the direction of C. Notice that C is perpendicular to A and C is perpendicular to B, but A and B could be perpendicular, but they're not necessarily perpendicular. So again, looking at that right hand rule, the first vector A, this is going to be A cross B. Put your fingers going in the A direction, bring them along that angle to B, and then your fingers going to point in that C direction. So setting up the cross product mathematically, let's say that we have a vector A that's 10i, 20j, and minus 3k. And let's say B is 1i, 30j, and 1.5k. There's kind of two main approaches to doing cross products, although there are some other ways to go about them. And the two main approaches are, one, to calculate them as a determinant. And the determinant is the unit vectors as the first row, so unit vector I, unit vector j, unit vector k. And then the second row is your first vector, the one that you're going to do A cross B. So this is vector A, this is the x component of A, the y component of A, and the z component of A. The next row is your vector B, so this is your second vector in your cross product. So this is your x component of B, your y component of B, and then your z component of B. Some folks feel comfortable doing a determinant like that. Some folks feel more comfortable by writing the first two columns over here again. And you can use two different methods, main methods in doing a determinant. One is a minor expansion. So if you've had linear algebra before, you probably feel comfortable doing a minor expansion. But if you've never had linear algebra before, let me show you a technique that you can use with the diagonals. And this is a technique that works with 2 by 2 determinants and then also 3 by 3 determinants, but this technique would not be a general technique, versus the minor expansion would work with 3 by 3, 4 by 4, and so forth. It's a more general technique. But this technique of doing the columns is that you find a diagonal and you multiply all three things together in that diagonal. So this term would be I times 20 times 1.5. The next term would be j times minus 3 times 1. And the next term would be k times 10 times 30. Now you can see why we wrote those two columns over again. Then these will all have plus signs in front of them. Taking your diagonals back the other way, it's going to be j times 10 times 1.5, and that one's going to have a minus sign in front of it. I times minus 3 times 30, and that one has a minus sign in front of it. K times 20 times 1, and that one has a minus sign in front of it. So let's look and see what kind of numbers those give us. We're going to skip this line and come down here. We'll go back to this line in just a sec. So looking at our I terms, the positive is I times 20 times 1.5. So there's our 20 times 1.5. And we don't have a negative sign in front of it. It's a positive term. Then we have I times minus 3 times 30. So be careful with your sign, because this is a diagonal going back this way. It has a negative in front of it, but the 3 also has a negative. So it's going to be minus 3, because it's the minus 3 is negative, times 30, and that's your other I component. Looking at your j components, you have j times minus 3 times 1. It's a negative term, but it has an overall positive sign in front of it. We don't change the sign of it. Then we have the other j, which is j times 10 times 1.5. So this is our j times 10 times 1.5. This is a minus, so we have a minus in front of that term. And then for our k's, we have k times 10 times 30. There's that one. And then we have minus k times 20 times 1. So there's minus 20 times 1 times k. So you can see how doing this determinant this way, looking at the diagonals, and again a minor expansion would also work, would give you this equation down here. Now the other way is to just memorize this equation. So this is the equation of the cross product. This is what you get if you took A and broke it up into its x, y, and z components and wrote it as a Cartesian vector like this. B is a Cartesian vector, and then you did the whole distribution and you got rid of the terms that zeroed out. These would be the terms that would be non-zero that you're left with. And when you look at this equation at first, you probably think, wow, I can never memorize that. This equation is actually really easy to memorize. Think about it as x, y, and z just kind of going along in a circle like this. So also think of x as being I, y is j, and z is k. So when you're trying to find the I component, you'll start off with the y term of your first vector. So this is going to be ay. It's going to be multiplied by then the z term of that first vector. Of your second vector, b. So again, you're looking at i's, so go along to y. It's going to be ay times bz. Then stick a negative sign, and then just flip your subscripts. So it's going to be minus az by, and that's your I term. Looking at your j term, your very next thing would be z. So it's going to be your first vector a, the z component, times the next thing, which would be your second vector b, x component. Then do a minus and just swap them. So this becomes minus ax times bz, and that's your other j component or y component. Then looking at your k component here, go along to your next one, which would be your x, and so then it would be ax times by minus, and then just flip the subscript. So it'd be ax times by minus ay times bx. So once you see the pattern in it, this equation really isn't as bad as it looks. And when you plug in the numbers, you get exactly what we got when we looked at the diagonals. So just going through and cleaning up the arithmetic. Once we get done, we'll have 120i minus 18j plus 280k. And you can see, as shown, this vector is then going in this positive k direction out here a little bit at an angle. So again, it's perpendicular to A, perpendicular to B. Notice if you flip the order of the cross product, so if you were looking at B cross A, you would wind up getting the negative of C. Thinking about this with the right-hand rule, this would be fingers going in the direction of B, moving your fingers around theta so that they go in the direction of A, and that's going to be a C now that's going down. It has the opposite sense now. It'd be negative C as opposed to this positive C. Thanks for watching.